Okay, I just thought I'd make a quick one to show you how to do linear interpolation. So I have here, I've just made up some numbers. It's the height of some students I surveyed at the school. I put their data into a frequency table, so a grouped frequency table. This is the format you're going to need to perform linear interpolation. So sometimes you may be given a histogram. You want to go to the table or make the table if one isn't there for you. So the first step is just to check actually, is there any gaps in your data? Do you need to extend the class bit boundary? So here, say this lowest class here between 150 and 160. The next class starts immediately at 160. There's no gap, so no heights have been rounded to the nearest whole number. That's fine. Just an example of a gap would be if you had maybe 150 to 160 here, and the next class started at 161. That wouldn't be very good. Okay, so what you'd have to do is you sort of make your own, you make the class boundaries proper. You say actually this is anyone between 150 and 160.5, and then the next one could start at 160.5. Okay, and so on. So you bring those boundaries to meet in the middle, and you use those as your boundaries. Don't have to do that here. So how do we estimate the median height? So this is just the basics of the interpolation. So the basics is, well, the median height, you need to say how many students do I have? I have, if you add up all the numbers, 10, 8, 7, 15, is 40 students. It's going to be really helpful to figure out every number I write, is it a student or is it a height? So 40 students. I want the median, so we're going to take the halfway mark, right? N over 2. You don't need to do n plus 1 over 2. This is continuous data. So with continuous data, we just divide by 2 for the median. We just divide by 4 for the lower quartile. If I'd asked you to estimate the 80th percentile, you would just take 80% of 40. Okay, it's just that. So 20 students. So if I lined up all my 40 students in line, I want to select student number 20. So which class will student number 20 be in? Well, the first 10 students are in that first class. You can even do cumulative figures down here if you want. Then the next 8 are 18 students, and the next 7 are 25 students. So there are 20 students in this class here between 165 and 170. So what you're going to want to do is zoom in on that class. So this class here, this class here. Now remember, every number, is it a height or is it a number of students? So let's do the height from the top. The lower bound for this class is 165, the upper is 170. Now, okay, there are 10 students below 160 height. There are 18 students below 165 height. There are 25 students below 170 height. So the 165 centimeter height mark corresponds to student number 18, if we assume all the students are spread completely equally throughout all the classes. Okay, this is kind of like student number 18 is right here, the top of this class, the top of this lower class, and the bottom of this class. And similarly, student number 25 is the very top of this class, but the bottom of this class. So we see student number 25 is right here, corresponding to 170 centimeters. We're interested, when we put them all in order, student number 20. So I know that my 20 has to go down here, okay, because these are my heights on the top. These are my frequencies, and 20 is a frequency. The number I'm asked to solve for is the median height, which is, a height, right? So that's call it x, it's my unknown. From this point onwards, you'll just find the number that lies proportionally between 165 and 170, in the same proportion that 20 lies between 18 and 25. So that might have been a lot of words. The technique is pretty simple. You say, well, what fraction of this bar have I covered along the top? And what fraction of the bar have I covered along the bottom? And it has to be the same fraction. Okay, so for example, fraction along the top is going to be x minus 165 out of the total, which is 5, or 170 minus 165. Fraction along the bottom is 2, or 20 minus 18, over 7, 25 minus 18, right? So I'm 2/7 of the way through the class. You can just solve this equation. Okay, it's a nice easy equation to solve. X minus 165 over 5 is 2/7. So multiply 2/7 by 5 and add on 165. And then let's round it. 166.4 centimeters. We'll leave it at 1 decimal point. Is this a sensible answer? Yes. I know it's in this class, and it is indeed. 166 is indeed in this class. So yeah, that's my only real tip, is just make sure every number is a height, is a frequency, or like a cumulative frequency, whatever. Okay, part B. Let's do part B over here. I'll try and keep it sort of on the same page, or in the same area, so we can look at all the information. I'll zoom out a bit. I want to survey the top 10% tallest students. What heights do I survey? What I mean by this question, I wrote it myself, maybe it's a bit messy, but I just mean how tall are the students I'm surveying if I'm just taking the top 10%, okay, of this sort of sample. So, similar idea. 40 students, let's do B, 40 students. I want the tallest 10%. So which students will that be? Well, 10% is 4. So the 90th percentile will be student number 36. So what I want is sort of student number 36 and upwards. Those top, well, that's kind of like 5 students. I guess if I want the tallest 10% of students, you might think that I want to go student 37, 38, 39, 40, but this is all continuous data, so you don't even need to think too clever about it. You just find 90% and you go upwards. If I wanted the shortest 20% students, okay, I'll just take 20% of 40, which is 8, and just find students 8 and below. It's a bit simpler than you think, okay, because it's all continuous data. So the 36th student, where does the 36th student lie? Well, the 36th student definitely lies in this last class, right? The first 25 students were here, and the final 15 were here. So I'm going to zoom in on that last class here, between 170 and 190. Okay, and I want, remember 170 corresponds to student 25, just like before, and then 190 will correspond to that very top student, student number 40. And I want student number 36. That 36 is going on the bottom, okay, students. And I want to know what height does that correspond to. So it's just sort of same idea, okay. Just phrased slightly differently. So again, you can even pause yourself, try and find x. We'll do x minus 170 over 190 minus 170 is 36 minus 25 over 40 minus 25. And then solve for x. So I'm just going to type in my calculator. I'm going to do 20 times 11 over 15 and add that onto 170, and hopefully I get a sensible number, 184.7 centimeters. That does seem sensible to me. So we'll say 184.7 centimeters and up. The height is greater than or equal to 184.7. Again, don't worry so much about saying, oh, it's the last 4 students, actually student number 37 and upwards, continuous. The same way we did the median was just n over 2, when really the middle student would be like, student 20 and 21 in between them. Okay, it's nice and simple. Yeah, that's a quick video, so hopefully that is helpful.